Hi friends, welcome to Just for Science. Today I am going to discuss about Pascal's triangle. It's a triangular array of binomial coefficients. Let's know about its different names in different places. In India, it was called Staircase of Mount Meru. In China, it is called Yang-Hui's Triangle. In Iran, it is called Khayyam Triangle. To much of the Western world, it's known as a Pascal Triangle after the name of French mathematician Blaise Pascal. Actually, Pascal had a lot of contribution to this Pascal's triangle. Now, let's know how to construct the Pascal triangle. To construct it, you have to imagine two zeros on the both sides of 1. Now, add 0 and 1, which is 1, and place it in between underneath. And now add 1 and this 0, and which is 1, and placed it in between underneath. That is like that. Again, imagine two imaginary zeros on the both sides and add them with 1. So add 0 and 1, you get 1 and place it in between underneath. Now add 1 and 1, which is 2, and placed it in between underneath, and again add 1 and this 0, which is 1, and placed it in between underneath. And with the help of these imaginary zeros in each row, we can construct the Pascal triangle further. Actually, this is the 0th row, and this is the first row, this is the second row, and so on. Now, what is the importance of this Pascal triangle? Let's start. First one, the coefficients of binomial expansions. Pascal's triangle determines the coefficients which arises in the binomial expansions. For example, you know x plus y whole square equal to x square plus 2xy plus y square. Here the coefficients are the numbers in second row of the Pascal triangles 1, 2 and 1. Similarly, for x plus y whole cube equal to x cube plus 3x square y plus 3xy square plus y cube. That is the coefficients in the third row 1, 3, 3, 1. And similarly, we can construct other powers. In general, x plus y whole to the power n equal to c0 x to the power n plus c1 x to the power n minus 1 y plus plus cn y to the power n, where coefficients ck are the numbers on the 8th row of this triangle. In other words, ck is nck, that is number of k combinations from the set of n numbers, and this is the binomial theorem. Now goes to the second importance. It tells us about the sum of the rows. In the 0th row there is 1, which is 2 to the power 0. In the first row, the sum of the numbers is 2, that is 2 to the power 1. Similarly, the sum of the numbers in the fourth row is 16, that is 2 to the power 4. So we can say sum of the nth row is 2 to the power n. Now, what will be the value of 11 to the power n? That can be also answered by the use of Pascal triangle. In the first row, that is 0th row, there is only 1, which is 11 to the power 0. Now, the number on the first row is 11, that is 11 to the power 1. The number on the second row is 121, which is 11 square, and so on. So each line is power of 11. Now goes to the fourth importance, which is it's a symmetrical triangle. That is, the number on the left hand side have identical matching numbers on the right hand sides. Look at here. Actually, the triangle is symmetrical about the central column. Look at the row where the numbers are in odd numbers, that is 1 to 1. Here the central number is 2 and both sides of it have similar numbers. And in case of the rows which have even number of numbers, there are symmetrical also about the central column. Now goes to the fifth importance. Look at the first diagonal, which have all ones. Look at the second diagonal, where there are only natural numbers. And look at the third diagonal, which carries triangular numbers. In the fourth diagonal, you get tetrahedral numbers. Now, what are triangular numbers? Triangular numbers are a pattern of numbers that form equilateral triangle. Each subsequent number in the sequence adds a new row of dots to the triangle. Here is one dot, here is another row which contains 2 dots. Here is another row also which contains 3 dots. Now, what are tetrahedral numbers? A number is called tetrahedral number if it can be represented as a pyramid with a triangular base and 3 sides. Here you get 1, where is only 1 dot. For the second tetrahedral number 4, you get 4 dots. Now, there is an importance about these numbers, that tetrahedral number is related to the triangular number. That is, the nth tetrahedral number is the sum of the first n triangular numbers. That is, let's understand it by an example. Suppose the second tetrahedral number 4 is 1 plus 3, that is the first 2 triangular numbers. Similarly, the third tetrahedral number 10 also can be written as the sum of the first 3 triangular numbers. So friends, end of the chapter. If you like the video, please like, comment, share and subscribe to my YouTube channel. Bye.